All right, now that we've taken a look at functions and what functions look like, we're going to continue looking at reading their graphs and working with properties of functions, section 2.3. So now that we've talked about intervals, and intervals always go from left to right because you're starting with where something starts to where it stops. We want to talk about what are called increasing and decreasing intervals. So let's look at intervals. Remember, with an interval, it's always about where you start and where you stop. Intervals always refer to the x's, to the domains. So I'm going to use the proper academic language, but an increasing interval basically happens when the graph is going up from left to right. An increasing interval means that let's do it this way, when the first x value is less than the second x value, when x sub 1 is less than x sub 2, okay? An increasing interval happens when the y value that's associated with the first x is less than the y value associated with the second x. So in other words, if I'm looking at this segment right here, of course, negative 10 is less than negative 9 because we're going to the right, so we're getting greater. But notice the y values. The y value associated with negative 10 is less than or below the y value associated with negative 9. This interval would be increasing between those two values. And we're going to get practice in just a moment. Decreasing implies we're going down from left to right. So I'll write it this way. I'll write it as a hypothesis and conclusion. If x1 is less than x2, so as I'm reading from left to right, okay, so as I'm going from left to right, so for example, from this point down to this point, our x value is still smaller than our right value, but our y value is larger than our y value. So the y value associated with the first x is greater than the y value associated with the second x. Okay, so we're going to practice some of this in just a moment with the example I gave you. Now, we want to take a look at a little bit more vocab. Basically, we're going to take a look at the difference between a local maximum or a local minimum versus the idea of an absolute or global. So if something is local, it's within an interval, okay? So if it's a local maximum, it is the highest, or the greatest would be better to say, but I'm going to say highest because we're talking about max. The highest y value within an open interval. In other words, endpoints are not counted. And again, we're going to practice in just a minute. Okay. Trying to decide which one to do next. I'm going to do absolute. Your author calls it an absolute maximum. Sometimes it's referred to a global, meaning global means over the entire graph, globally. Local means within a certain piece of the graph. Global, the whole thing, or absolute. This is the highest or the greatest y value within the entire closed interval. And the same idea for the minimum values. So I'll let you finish these out, but I'll write them. Local minimum, well, minimum implies small, so we're looking for the least or the smallest y value. If it's local, it's open. And let's finish out with a global, or what's also called absolute minimum. And this is the least or the lowest y value within a closed interval. Okay. So let's practice a little bit before we start looking at some other things. So I did provide you with a graph. I did provide you on Canvas for this year's BHS students. I did provide you with this exact same document. I'm just going to put this here so we can see. If not, you feel free to copy it down on your paper. Okay, I'll give you a few of these values to make it a little bit easier. -7, -5. This one is 7, -4. 5, 0. Well, you can see that that's 10, so it's 9. This is 0, 2 for a y-intercept. Okay, so there's a few points on here. And let's take a look at these and answer a few questions. So first of all, we're going to start off with a yes or no. Is this function, f of x, increasing over, and I want to have you really watch how I write this, okay? For right now, I'm going to put the word in over the interval. In the future, we're not going to have that. It will be implied. I want to reiterate, this is not a point. Not a point. This is an interval, which means that, remember, that means we start at -7 and we stop at -3. So if I start at -7, okay, so as I read from left to right, here's where x equals -7. And it says keep going, the interval, that's all the x values from left to right. X starts at -7, x excuse me, stops at +3. So I want to know, as I go from -7 to +3, is this graph only going up? Well, I can see that it goes up and then comes down and goes up. So it is not increasing because, oh wait, that says -3. I'm so sorry. If I go here to negative 3, well, that looks better. Let me start over. Is it increasing over the entire interval? Between x being negative 7 and x being 3, are all the y values going up? Well, since we always read from left to right, these are going up the whole way. So f of x is increasing the entire way. Let's look at our next question on that notes template. Is f increasing on the interval? So I don't have to put the x in if it's written as an italics f. Is this function increasing? And I'm going to keep the word in here for a while, but then eventually we're going to get rid of interval because increasing implies movement. Movement can only happen over time, if you want to think about it that way. And I'm going to ask you, is it increasing over the interval from positive 3 to positive 5? So we're starting at 3 and we're stopping at 5. So if I keep this going, x is starting at 3. All right, there's x being 3, stopping at 5. Here's x being 5. So as I read from left to right, is our graph increasing? No, it looks like it has a negative slope going down to the right. So this would be no. It's actually a decreasing function during that open interval. Is our function decreasing on the interval from 5 to 7? Remember, that's not a point. In fact, if you try, 5, 7 is not even on the graph. Decreasing implies movement. It implies something's going down. Is the graph decreasing from x being 5 to x being 7? Well, if you're visual, start at 5, end at 7. So the question is this function decreasing or going down? And the answer is, as I move left to right, yes it is, it's going down. Very important to know how to read the graph and the data that you're given. Okay? And now let's go the other direction. Okay, actually let me ask you this one. Is this function increasing, decreasing, or neither? Over -10, -9. Again, increasing implies movement. That's an interval. Decreasing implies movement. So that's an interval. Neither implies it would just be constantly. Or it undulates. It goes back and forth from -10 to -9. Well, x being -10 is right here. X being -9 is right here. So if I look in this neighborhood or in that interval, it looks like as I go from left to right, the graph is increasing. Same question. Is this function increasing, decreasing, or neither? over 0 to 5. Remember, that's not a point. Not a point. Increasing implies movement. Decreasing implies movement. So let's look at 0 to 5. If I go between 0 and 5, x is 0 right here. So I'm going to start when x is 0. I'm going to stop when x gets to 5. So I want to know, is this graph increasing only, decreasing only during that interval? Well, it sure looks like it increases, and then it stops, and then it decreases. So it is not increasing only, it is not decreasing only, because it did both. Therefore, it is neither increasing nor decreasing because it did both. Well, now let's go the other way. List the intervals on which f is increasing. So we might have more than one answer. Now notice it says interval. So I need to, an interval always has a start and a stop. So I'm thinking about intervals where it's increasing. Okay. I see my graph as I go from left to right, always from left to right. So I'm way down here, increasing, 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 increasing. I stop going up, then I go down, 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 stop. Then I go up, 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 stop, go down, stop, go up, stop, go down, stop, go up. I want all the places where it's increasing. So all the places where it looks like it has a slope that's positive, that it's going up. So I'm going to start at the far left because we always go left to right. Well, this implies the graph goes down forever to the left, which is exactly the same as saying it's going up to the right. So I'm going to start with the opposite of infinity, way, 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 way out here. It's going up, 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 stops when x is at -9. It's open because at x being -9, it's come to a stop. Well, when you've stopped, you're neither increasing nor decreasing. Now it's decreasing, 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 stop. Now it's increasing. So what I'm going to unite this with, this is a united with, combined with, now it's going up between x being -7, up, 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 and x being -3. But then I get to -3 and it stops, because what goes up must stop before it can fall. Going down, now it starts going up again between 0 and 3. Down, 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 down. Up, starting at 7, and it's going up forever. So it's going up to infinity. And you can never touch infinity, so it will never equal infinity. And let's finish listing out all the intervals which are decreasing. Decreasing implies going down. So once again, we are going to be listing a start and a stop of anywhere the y values are going down. So again, from left to right, it's going up, 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 stop. Now it's going down. So it's going down between x being -9 and -7. And I'm going to unite that with the next place it's going down, from -3 to 0. You keep going, I'll do it as well. So it looks like it has 3 intervals of decreasing. Okay, so we talked about intervals. Let's look at some of the max and mins. And then we're going to take a look at even and odd. And then we're going to look at slopes of lines. I'm going to keep the same picture. Let's take a look at where is, or is there a local maximum? I think we left off with H. Is there a local maximum at, I lost my place, -3? If so, what is it? Well, a maximum, okay, a local max. A local max is basically any sort of peak or valley. So for example, as I read from left to right, I've reached a local maximum right here. I've reached a local minimum. I've reached a local max, local min, local max, local min, if I define it over a certain interval. Well, a local max, is this the highest value on the graph? This is where it's occurring. Is there a local max at -3? This is implying when x is -3, we want to know what is the y value. So when x is -3, y is 5. That is a local maximum if I'm between this interval, for example, or this interval, or this interval, or this interval, okay? So it does occur, so yes, okay, where does it occur? It occurs at 5. Do not give me the point, only give me the highest value. That's that y value. That's a local max. Is there a local max at 9? Remember, that refers to the x value. So, okay, where are we going? We are going to 9. When x is 9, notice where we are. When x is 9, we're sitting right here. Is this particular point a high point in our graph? Do we go into like a peak? Well, the answer is no. It's sort of in the middle of this increasing part. So is this a point where there's a turn? And the answer is no. So therefore, it's not a maximum because we didn't come up and then go down at that point. Okay. Hij, is there a, make sure I've got the right one, local minimum at -9? Well, if I go to where x is -9, right there, is at -9, is that a minimum or is it a maximum? Well, because it's at the top, it's at the peak, it's a maximum. So is it a minimum? No. It's actually a maximum. Okay, so it's actually a maximum. What is it? It is a local maximum. Okay. List the numbers where f has a local max. List where the function has or have a local maximum. I'm going to make a list. What are the maximum values? About reading. Where is your x values? Where are your x's? So we want to know where we have local maximum. So as I read from left to right, it sure looks like I have a maximum here at -9. I have a maximum here at x equals -3. Then I dip, I have a max at x equals +3. So that's where they are. That's the x values. What are they? That's asking you for the y values. What are the maximum values? Well, the y value at this first minima, at this first local max, is -1. And if I keep going, my y value at this next maximum is 5. My y value at this other maximum is 7. So it should look like the coordinating points, -9, -1, -3, 5, 3, 7. And we can do the same for the local minimum. Hij, list where f has a local minimum. And then, what are the minimum values? So where describes how to get there. Where describes your x values, because that's where you always start. So where are the minimum values? Well, as I read from left to right, I have a minimum value at -7. I have a minimum value at 0. And I have a minimum value at 7. Okay. All right, so we list where it is a local. So where describes the x value, where is it occurring? So the local minimum occurs where? Well, there's no minimum here because it goes to -infinity. It occurs where or when the x value gets to -7. What is it? It's -5. Then the next time it dips is when x is 0. What is it? 2. And the third minimum, local minimum, would be 7, and -4 is what it is. Okay? Then if I asked you for a global, if it asks you for a global or an absolute, the absolute max would be the absolute highest point on the graph. Highest value. I cannot include infinity as a high because you can never touch infinity. So the global max would be the highest y value. Well, in this case, it's going to be the number 7. That would be our absolute or global max, because I cannot touch infinity. The absolute minimum, what would the absolute minimum be? It sure looks like the absolute minimum is -5. Where does that occur? At -7. So this value, -5, can be both. It can be both a local, if I'm talking about a small interval, but if I'm talking about the absolute, it can also be an absolute minimum. Okay. So that part probably takes the longest of the entire section, mainly with the description. Now this next part, what's really cool is we already did it in chapter 1.2. So if you've already done your 1.2 when we talked about symmetry, and if you remember you're symmetric with the x-axis, the y-axis, this next part will go very quickly. Okay, so very, very, very fast. The definition of an even function. I'm not going to go back over all the parts and pieces because we did this in chapter 1.2. The definition of a function which is even is a function with y-axis symmetry. We've done that. Function with y-axis symmetry. Well, here's the y-axis. So let's say, for example, I take the absolute value function. That has y-axis symmetry because if I pick a value, any point on the graph, x, y, if I go across the y-axis and I replace it with the opposite of x, y, I get the exact same equation. I get the exact same function. That's called even. The definition of an odd function is a function with origin symmetry. Well, again, I'm not going to go back over section 1.2. We've already done that. Origin symmetry. Say I give you the cubed root function. Not the cube, but the cubed root function. Origin symmetry said if I give you any point x, y, and I replace it with the opposite of x and the opposite of y, I will get the exact same equation, exact same function. So we already know those. So from now on, you don't have to say a function with origin symmetry. You can just describe it as odd. Now, what about x-axis symmetry? You know what this looks like. If I have a function, if I have an equation with x-axis symmetry, maybe I give you a parabola that is a y-squared parabola. Well, notice we already know how to find this. If I take any x and y and it reflects over the x-axis and I replace it with x opposite of y, we have a problem. Because by definition, this is not a function. For every x value, a function can only have one y value. And you'll notice for this x value, we have two different y values on the same graph. So this is not a function. So there is no such thing as a function with x-axis symmetry. So you already know how to do x and y axis symmetry, x-axis, y-axis, and origin, so now you have even or odd. The last thing I want to touch bases with you on is slope. We talked about it a little bit before. Now we're going to give you an actual definition, and we want to talk about average rate of change. Only now we're really using the academic language because the average rate of change is the slope. Well, again, you've had algebra. You've had algebra 2. You've had geometry. You had this class in chapter 1, section 3 with lines. You know how to calculate slope. So let's actually use the real function notation. Okay? So I'm just going to do this. Given 2 points on a function. So we already know for every x there's only one y value. We already know it's a function. I'm going to call this x sub 1 f of x sub 1, our second x value, and the y value that goes with it. Don't make it harder than it is. You already know f of x is the same as y. You already know f of x is the same as y. So our average rate of change, which is known as the slope, you already know it. y2 minus y1 over x2 minus x1. y2 minus y sub 1 over x2 minus x1. It's exactly the same as what you have done in the past. It just looks different. Okay? So let's look at an example. I'm going to give you the following. I'm going to give you f of x equals, we'll do this one, x squared minus 3. And some of you already know what that looks like. This is the same as y, so y equals x squared is a parabola that's been shifted down 3 spots. Okay, so we already know what it looks like. What I would like you to find the average rate of change. I can't call it a slope on a curve, so we're going to call it the average rate of change from do I want to do the general or do I want to do, let's just go from 1 to any x value on the graph. So what I'm asking you to do, for those that like a visual, I know this graph looks like the following. And don't worry, we'll be doing this again in another couple of chapters, so if you don't remember, that's okay. I know that it looks something like this. want to find what the slope of this curve is. Now you'll notice if I take a line, notice and I put the line right there, tangent to that curve, the slope of this line is negative. If it touches the curve, so it's tangent, the slope of this line is negative. If it touches right here, the slope of this line is 0. As I move it, now the slope is positive. Just look at the ruler. The slope is positive. The slope is positive. So it changes depending on where we put that line. A secant line hits the graph at 2 places. So what I'm asking you to do is find the slope from 1 to any x value on the graph. Well, here's x equals 1 on the graph. So notice if I start, here's the point on the graph where x equals 1. In fact, if I plug 1 in, this is 1, negative 2. If I pick this if I pick this x value as 1 and I go to any x value, let's say I pick an x value that's negative. Do you see here that if I choose 1 and I choose a point over here that slope is negative? But as this changes, still negative, now the slope is 0. Now the slope between these 2 points is positive. So this changes depending on what the x value is. That's what's called a limit. That's what's called the derivative in calculus, the slope of a line. We're just going to do this mechanically. You know this means slope. You know how to find slope, change in y over change in x. This is an interval. I know in order to find slope, I need 2 points. Well, since this is an interval, I've already given you the x values. I have given you the point 1 something, and I have given you the point x something. Okay? So I gave you the x values. I gave you from 1 to any point on the graph. Well, you guys, think back to pre-algebra. If I give you x as 1, how do you find the y value that goes with 1? You substitute it in. F of 1 would be 1 squared minus 3. F of 1 would be negative 2. We already wrote that down. Don't make this harder than it is. You already have x. So if I substitute in x, you already have the answer. F of x is x squared minus 3. And now you have your 2 points. Simply find the slope. Average rate of change is the slope. You already know how to find the slope. y2 minus y1 over x2 minus x1. Average rate of change, same thing. y2, the y from the second value is x squared minus 3. Minus the y from the first value is negative 2. So there's my y2 minus y1, y2 minus y1, divided by x from the second point minus x from the first point. Now comes algebra 1. Simplify the numerator. Simplify the numerator. Now you must factor, or use long division, or use synthetic division. You must use algebra 1. The This will factor difference of squares. You do it right, every single problem will work out perfectly. It'll come down to the factoring. You can reduce common factors. So your average rate of change from x to any point on the graph, from 1 to any point on the graph, can always be found by x plus 1. So if I ask you to find the average rate of change of the exact same problem from, say, 1 to 5, I'm going to bring this over here. I want to leave that there because I want to show you something. There's a shortcut, but there's also common sense. So I'm going to keep going over here. Find average rate of change from 1 to 5. I'm going to show you the logical way to figure it out, the way that always works. 100% of the time, you learned it in algebra. You did it again in algebra 2, geometry. This would imply it is the point 1, f of 1. This would imply it is the point 5, and whatever the y value is when you substitute in 5. Well, you already know how to find f of 1. We've done it. X squared minus 3. So we already found f of 1 to be negative 2. We already did that. What's f of 5? Well, substitute in 5. 5 squared minus 3. 25 minus 3. So you guys, you already know how to find slope. I'm being redundant here. I'm doing it on purpose. You do not have to work it out this way. In just a moment, I'll show you why. But when in doubt, work it out. So we know the slope is y2 minus y1 over x2 minus x1. Okay? That's exactly the same as 22 minus negative 2 is 22 plus 2, which is 24. 5 minus 1 is 4. Okay, slope is 6. There's a faster way to figure it out. You didn't have to do that. But if it makes sense to you, of course you can do it that way in this class. Of course you can. What I'm trying to point out, though, is in the problem, we figured out the average rate of change from 1 to any x value. We found out the average rate of change from 1 to any x value is x plus 1. I asked you to find the average rate of change from 1 to 5. Well, if you knew the slope was, or the average rate of change from 1 to x is whatever the x value is plus 1, all you would have had to do was say slope equals from 1 to 5. That's going to give me 5 plus 1, 6. So the slope of this secant line in the general form, slope of the secant line, working it out using algebra, does not matter to me. Okay, so we'll practice more of these, but I want to get you one, but it's kind of getting long on this lesson. So look that over. If you have questions, make sure you come to tutorial. Okay. And next time we'll be looking at section 2.4.